Alright, 15.4, impact. So it says here, impact occurs when two bodies collide. Alright, we've already seen this quite a bit in the previous sections. Two bodies collide with each other during a very short period of time, okay, causing relatively large impulsive forces. So, for example, I think it was example 15.5, we'll get to this in a minute, where we had the two bumper cars going at each other. Then they collided and they had perfect rebound, okay, no energy was lost, okay, and what we find is that this, we'll introduce this in a minute, but that example 15.5, we had something called a coefficient of restitution E, and it wasn't introduced then, but it will be introduced now, where if you've got perfect rebound, no energy is lost, then you've got a coefficient of restitution of 1. There was another example, I think it was 15.4, example 15.4, where you had the two trains coming at each other, and they collided and they coupled together and they began to move in the same direction. So they coupled together. In this case, they had perfect rebounding. So you had something called the coefficient of restitution equal to 1. In this case, the coefficient of restitution is equal to 0. These are the two extreme cases where basically you have two particles coming at each other, they collide and they kind of stick together, which means there's no relative velocity at state 2. There's a relative velocity at state 1, but no relative velocity at state 2. And so you've got something called a coefficient of restitution E equals 0. But if we've got a relative velocity at state 1 and relative velocity at state 2, and you've got this perfect rebound, you've got E equals 1. So what we're going to show you is that these are the two extreme cases, but you can also have coefficients of restitution between 0 and 1. So E can be between 0 and 1. And what E allows us to do, basically, maybe a few more things, but it allows us to calculate the velocities of the particles after collision. That's one thing that it allows us to do. And it also allows us to calculate how much energy we've lost during the collision. For example, in this case of 15.5, where you've got perfect rebounding, you lose no energy. Okay? We had the conservation of energy. Whereas in this case, we might have lost some energy, and we want to calculate how much energy we lose in the collision. Okay? Alright, so this impact, this entire kind of description will ultimately lead us to this thing called the coefficient of restitution. Okay? And then we'll do some examples. Okay, so I'll see you in the next video where we will go in detail through how we derive this coefficient of restitution E. Okay? Cheers.